So solving logarithmic equations. So now our variable is going to be tucked into the logarithm. And there are some rules there, and it says isolate the expression, maybe get the same log on both sides. But it'll feel kind of similar to what we do with the exponential. So could I get this logarithm all by itself? By doing what? Not yet.
So dividing by 2 is not right.
Yeah, dividing by 2, right? Is that what you said?
Yeah. No, that's what you said.
Okay, so if I divide by 2, I get the logarithm of x is equal to 5 halves, or some of you might write down 2.5. What base are we in? So a lot of times in the logarithm problems, if it's not there, I like to write it in, because then what do you do when you go to write it in exponential form? How do I write this in exponential form? Your log base is 10, your exponential base will be 10. Logarithms are always equal to the exponent. So 5 halves is my exponent. There's only one spot to put x. We're done. X is 10 to the 5 halves, or 2.5 power, which is approximately 316.227. Good enough. 10 squared is 100. 10 cubed is 1,000. So you can kind of estimate your answer will be somewhere between 100 and 1,000, which is quite a range of outputs. But at least when you come up with 25,692, you know you did it wrong. Okay. When you look at this one, parentheses, extraneous solutions, what is that telling you? You can end up with some, you can do something mathematically correct that's going to create some solutions that don't work. So we have to, at the end, be careful. Here is what I kind of think of in my head as the one-to-one property. We have an equal sign that tells me left and right are the same. And both logarithms are the same base. So their stuff, what can we do with this? What do you know about the square root of x plus 2 and x then? They have to be the same. Right? So we're just going to take x plus 2, set it equal to x. All of a sudden we're doing a square root problem like we did back in what, P4, P5. How do you get rid of the square root? Square both sides, and I get x plus 2 is equal to x squared. I'm going to pause it for about 30 seconds, and you should be done with this quadratic. Go. So the number one thing is we want to get this thing equal to 0. So I would move those guys to that side. And I'll put it up here so you can see it. X squared minus x minus 2. X and x minus 2 plus 1. So I get 2 and negative 1 for my solutions. Anybody agree? Okay. And I was being a little sarcastic when I was talking about do the quadratic in 30 seconds, but what's going to happen is in this logarithm exponential unit, we're going to run into the quadratic a lot still. So you got to still maintain, I guess, your skill level there. I will tell you one of these is extraneous. Why is the negative 1 extraneous? It's okay actually on the left-hand side, right? Because negative 1 plus 2 gives me a 1, square root of 1 is fine. But it's when you plug negative 1 into x, I cannot take the logarithm, in this case the natural log of negative 1. You can't take the logarithm of negative 1, so you want to be careful. Just a nice dotted line x to show us you understand it does not work. You found it, but it doesn't work. Of course I will.
Did you write find the extraneous?
I will not remind you to find extraneous solution.
I like to
The other thing we want to look at is, on a problem like this, a lot of you might feel you want to do what we did on the last problem, like get one of the logarithms on the other side, right? So that you have a log on both sides and you can set their stuff equal to each other. But the problem is, if I move that log of x minus 3 to the other side, like if we do log of x equals 1 plus the log of x minus 3, am I creating the one-to-one property here? Why? Because this guy's hanging out there. So I don't have just an isolated logarithm on both sides. And there's nothing we can do, so we have to handle it differently. So in your head there might be, when you see more than one logarithm in a problem, you might think to try that. The other thing is squish it together. Condense it. Write it as a single logarithm. How do you take two parts that are being subtracted and nice, thank you. And what base are they? 10. So you go log base 10. You do x divided by x minus 3. Because we are subtracting, we divide the stuff. And now I have actually written it as one single logarithm. So to solve it, we'll go into exponential form. What's exponential form? What's my exponential base? 10. Logarithms are always equal to the exponent, so 1 is my exponent. I'm going to pause it again and let you guys work on that. Go. So this is 10, and you could multiply both sides by x minus 3. So 10 times x is 10x. 10 times negative 3 is negative 30. Or you put the 10 over 1 and do your cross multiplying and you end up at the same spot. I need to subtract the x and send the 30 that way. So when you subtract the x, I get 9x. Add the 30 to the other side. Divide by 9. X equals 30 over 9, or 10 thirds.